Hello, I think we're live now. Welcome everyone. It's good to see so many of you in the chat already discussing and ready to start. Mixture of opinions about circles and kind of gearing up for GCSEs this year. Hope we're all well. Please do say hi. It's great to see so many of you here already. Yeah, we're going to get started shortly. So it's been a strange year already, I know, shaping up to be kind of an interesting one in terms of exams and education so far. Hi, welcome. Do say hi if you haven't already. It looks like a few of you have begun on the discussion about circles and the topics we like and stuff. So that's great. Welcome to everyone. We're about to get started now and look at this topic and just to kind of from the basics onwards into exam questions and sort of building up as we go. So welcome. And as I said, there's going to be some questions that we'll look through together, but I'm also going to talk to you a little bit about what we have in store, as well as some potential prizes, free accounts and bits for revision and extra tuition and support for maths and your other subjects. So I'm going to share this now. Hi, excellent, welcome. I'm going to share my screen so we can get started. Let me just make sure I can do that. And you can all see what I'm hoping to share with you. Here we go. So hopefully you'll be able to see my PowerPoint shortly and we'll start working through. Please do ask any questions, share answers in the chat as we go, and it'll be good to hear from all of you moving forward. But hopefully we're all well and ready to make a nice start on this topic. So welcome for GCSE Maths, and we're going to look at circles today as the topic. Right, let's get started. Lovely. Okay, so that's me. I'm Max. I'm the head of maths at Snap Revise. I did a maths degree a few years ago and have been teaching A-level maths and GCSE maths and below for the last 4 years. So I've seen the kind of courses change as well. They changed in 2017 and the new GCSE and A-levels have sort of come into play now. Obviously, this year is looking a little bit different, but the content is very much the same. So I'm going to work through circles today, and it'd be great to hear some answers and questions if there's anything we're struggling with, which will be good. So just to start with and talk about Snap Revise and what is on offer in terms of the GCSE and the tuition that's provided. There are going to be 4 or more classes per week that will be running on our platform, and the full curriculum will be covered. So there's lots of high quality handouts. The revision resources produced by Snap Revise are brilliant. It's so easy to learn from and certainly helpful if you're thinking there's a particular topic you've really got to sort out and understand fully. And we're probably thinking about what we're looking to do after this year. Perhaps some of you are in year 10 and you're thinking, right, I've got GCSEs next year and then I don't know what subjects I want to take on. This will be a good insight and a good overview to the whole course. So the resources that are available are superb, as well as a library of previous recordings. So if a topic has been covered and you missed it, you can go back and look at that as well. So lots of one-to-one support and essentially extra tuition for your GCSEs. So if that's something you're interested in, I'm just going to move this on. I'm just going to talk about this thing quickly. We're going to do a 10 accounts giveaway. So if you enter your email link and basically sign up for the mailing list, we're going to give 10 accounts away for the rest of the academic year for free. So you've got full access to the resources we provide, which would be really handy and hopefully kind of nice if you win that. So that'd be great. As I said, I'm going to start looking at circles shortly, but do make a note of this because this might be something you're interested in. And as I said, we're going to carry on with more sessions. There's more YouTube sessions coming up and we'll talk a little bit about that at the end. Right, excellent. So welcome to anyone else that's just joined. We're looking at circles today. And for some of you, I can see from the comments, you've met some of the ideas before, and this might just be revision. For others, this might be quite new, some of the stuff we cover. So the key objectives from today, we're going to look at the main components of the circle in terms of the names of each part, because that will be crucial as well. We're going to look at pi, the number pi that some of you have mentioned in the chat already. It does tend to confuse people. but we'll talk about that and what it actually is. Looking at the circumference and the area of a circle. The things I won't particularly go into specifically today are things called sectors and segments. They're sort of an extension of this, and circle theorems. That's a kind of harder idea that builds off the back of the basics from circles. So what I'm going to do is move on and we'll get started. The key things to start with then, so just an indication in the chat would be really great. Could you let me know if you've covered this stuff before, if you know what the area of a circle and the circumference of a circle are and what they're defined as? Do give me a good indication of if this is something you know or if this is actually kind of brand new information. Let me know, that'd be great to see, and thank you to those that are already kind of conversing in the chat. And good, yeah, there's a few people that this is perhaps something we've seen before. Brilliant. Right, so key things to just remember: areas and perimeters. A perimeter, we should hopefully be happy that a perimeter is essentially the total length of all the sides. So for a polygon or a rectangle or a 2D shape with straight sides, it's the total length of all of the sides added up. So that's kind of a prerequisite idea we need to know. We need to be happy with that. And the area is basically the 2D space inside the shape. So they're two different types of quantities. The area is the space taken up by the shape. And hopefully that's something we've seen before, maybe for some slightly more straightforward shapes. So this bit in here is essentially the area. And does anyone know what units we would generally use to measure that? Some examples of units for area. Excellent. So area in the shape, it might be measured in centimeters squared, it might be meters squared. It's basically a squared unit. So something squared is an area. And the lengths all around the outside is the perimeter. So the way I like to think of the perimeter, so that I remember it's a length, is if you imagine you had a bit of string and you put it around the shape and then you held it out, how long the string is essentially the perimeter. Excellent. Lovely, and thanks for that. Good, some really good suggestions of units in the chat there. So the units, for example, meters, that would be a measure of length. So that would be for the perimeter. And then meters squared, that one would be more for looking at the area. So, oops, there we go. Meters squared, as some of you have mentioned, is area. So these are kind of the key bits of information and ideas we should be familiar with before we start looking at circles. Now, looking at the different specifications, obviously you may be aware different exam boards have slightly different styles in how they approach the topics, but circles is a topic that's common across all the exam boards. So in their specifications, they really clearly outline what will be in the exams. And as I said, since 2017, around that sort of time, the exams were very much kind of stated as what will be kind of required for all exam boards. And the stuff we do at Snap Revise and the resources we produce are really tailored to the new content. So if you're looking for questions online, there's lots of resources out there, but do make sure as well your practice is worthwhile and it's relevant to the GCSE. And that's what we're going to look at today. So, circumference, we're going to have a little look at this first of all. So the first thing I want to do and break down here is the idea of the kind of different terminology we use for circles. So this green line here, does anyone know what we refer to that? This is the line, a straight line that bounces off the circle from the outside at one specific point. So here, one specific place, this line meets the circle. Does anyone know what we would refer to that line as? So there's some key words. Excellent, lovely, Lauren. Oh, excellent, loads of answers coming in and they all seem to agree. This is called a tangent. And you may have heard people use the phrase, I'm going off on a tangent. That basically means they're on a certain idea and they start drifting off and talking about something else. That is what we've got. We've got a tangent if it sort of runs away from the circle but touches it at one point. So that's great. Right, I've had some other suggestions coming in for names of these lines. Absolutely right. The red line is called a diameter. That is superb. So the diameter is the whole way across the circle. Brilliant. And we've got some other answers coming in. I'm trying to keep up with these. Excellent. The blue line, that's one people struggle to remember. That's called a chord. So a line that sort of chops the circle up randomly inside the shape, goes through the circle, but not nicely through the middle, is called a chord. Superb. Let's see if we've got any others. Now, half of the diameter, this is one that's going to be quite useful for today, we call the radius. So you might think about where we'd see radius in real life. Maybe for a CCTV camera, it would have a certain radius it could see round to, or your Wi-Fi, there might be a radius and then you'll sort of drop the Wi-Fi. So kind of a key idea in sort of practical terms as well. And there's one other keyword, which is the thing we're looking at, the circumference. Does anyone know what the circumference actually is? Yeah, superb. The maximum length of the chord is actually the diameter. If the chord was straight through the middle, that's the longest it could be. The length around the edge, which for other shapes we were referring to as the perimeter, that whole length there is what we call the circumference. Okay, so the length around the circle is what we would refer to as the circumference. So essentially, if you put a string, it is the perimeter. Excellent. It is essentially the perimeter of the circle. So I know there's a lot of keywords and terminology going on here, so we're going to break it down bit by bit. But the main sort of one we're looking at now is the circumference. So if you put a piece of string around the circle and then held it out straight, the length of that would be that curved length. And the special name for the perimeter of a circle is the circumference. Lovely. Right. So we'll move on and we'll actually have a little look at some calculations. But first of all, we have to meet this idea of something called pi. And it's really interesting when we try and define what pi is. It really confuses people. They don't like the fact that it's a Greek letter and it's got a weird name. And is it a number? What is it? It is a number. It's a number with lots of decimals, an infinite amount of decimals. But actually, we just need to kind of work out what it is and how we use it. So essentially, the definition of pi is, let me make sure I've got the right pen here. Here we go. Is the ratio between the diameter and circumference of any circle. Okay, and I'll just clarify what I mean by that. Of any circle. It's basically a scale factor that links you from the diameter to the circumference. Yes. So I'm going to talk about specifically what you need to know in the exam, but I'm glad we're trying to pick out these key things. So pi as a number, if you've got a scientific calculator and you go, you know where the pi button is, you go shift, and it's the one near the bottom next to the answer button, the one that says times 10 to the x. You press that and it will say pi. If you press equals and turn it to a decimal, it will say pi is equal to 3.14159, blah, 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 and it will go on infinitely or basically till when your calculator gives up or runs out. Okay, so it's about 3. And if you want the exact value, we denote it with this Greek symbol here, pi. If you want it to a rounded decimal, you could use your calculator. But how do we work out pi? It's basically the circumference of a circle, the circumference, which is like the perimeter, as we said, divided by the circle's diameter. And what's really cool is if you did that with any circle, any perfect circle, if you took the length of the outside and you took the length straight through the middle and you did the division, it would all have this number, 3.14 and so on. Depending on how accurately you could measure it, would be how many decimals you'd get it correct to. So this is a really important kind of idea for the GCSE, But even further than that, understanding how circles work applies to many different fields in terms of engineering, in terms of anything vaguely mathematical. This is a crucial idea, understanding circles. And so pi is this special number that gets us from the diameter to the circumference. So if you know how far it is straight through the circle and you times it by this number, that will tell you the length of the outside. Yeah, so I know obviously a key thing that's playing on everyone's mind is the assessments, and being only in January, I'm quite sure that going forwards, it's looking very likely that in some way or another, assessments are going to have to take place. But I understand the dilemma we're all in. There's still this sort of uncertainty, but I think the key thing is still cracking on with these big major topics, because it's likely that they're going to form the basis of any sort of assessment that goes on. But yeah, so pi is 3.14 and so on. And basically what that means is if we have the diameter, if you times it by that number, approximately 3, that will give you the length all the way around. So the diameter, remember, was straight through the middle. That's the diameter there. It crosses the center and it's a length. And if you times that by 3.14 and so on, it would give you the whole circumference. So that is basically what pi is. It's the link from the diameter to the circumference. So this is applicable for Edexcel, AQA, OCR, and all of the boards. So a really good question. As I said earlier, this is a topic that will be on the GCSE regardless of what exam board you're using. So it is really pretty important. Excellent. Right. Yeah, I'm going to try and keep the writing nice and neat, but please do ask me if you need anything clarified, and I'll try and keep up with what we're doing and how we're getting on. So the formula for linking the circumference and the radius is basically 2 pi times the radius, and some people denote the radius as r, 2 pi r. Now, if you think about it, 2 times r, doubling the radius gives you what? What is double the radius? Now, some of you might have seen it as this formula before, but what is 2 times the radius? If you double the radius length, that is essentially the what? The diameter. Excellent. Well done. So an easy formula for the circumference is that the circumference is just pi times the diameter, which we've just seen. So the circumference equals pi times the diameter. But if you're not given the diameter in the question, but you are given the radius, we can times it by 2 and then times it by pi. So here it says, calculate the circumference of a circle with radius 5 centimeters, and then a separate question, 4 meters. So let's do this. The circumference, and please feel free to share answers in the chat if you haven't already, but let's see how we get on. So the circumference is going to be 2 times pi times 5 centimeters. And that will be excellent. In terms of pi, it will be 10 pi centimeters. And pi is approximately 3. So if you use the button on your calculator, excellent, lovely. Brilliant answers there, 31.4 centimeters. So if you wanted it to 1 decimal place, it would be that. If you wanted it in terms of pi, that would be the answer. And well remembered that we should use the units for the length. That was superb. Right, so 3.14 is the value of pi. So for those that are thinking, what is that really still? It is just a number. It's just, we give it a symbol to denote the fact that it's not a nice whole number. And it's essentially the scale factor you times the diameter by to get you the circumference. Lovely. Right, so for 4 meters, if we were doing this circle where the radius is 4 meters from the middle to the edge, the circumference will be 2 times pi times 4, or 2 times 4 times pi, same thing. Double the radius would be 8 times pi. And on your calculator, you could do that. 8 times 3.14, blah, blah, blah. Use the pi button and it will come out as 25.1. And remember, this question was in meters. Excellent. And some people have done equivalent answers of that and rounded. Lovely. Thanks very much if you shared an answer there. That's brilliant. Cool. Okay, so we've got to remember our units and so on as well. That's lovely. So I'm going to keep going, but thanks again so far to everyone sharing those answers as we go. That's brilliant. Right, here we go. So next thing, we can do a few more questions now. So now it says, calculate the circumference of the circle with diameter 12. So you could do, what's the radius? And then I'll times it by 2 and times it by pi. But remember, the circumference is literally just the pi value times the diameter. So all we have to do here is the circumference equals pi times 12, pi times the diameter, which is, so you could write it as 12 pi. Has anyone got that as a decimal value for me? Excellent, some of you beat me to it. Brilliant. The diameter divided by 2 is the radius. Excellent, so you could have used the other formula, but then you're timesing up by 2 anyway. So it would have got you straight there. Absolutely, it's 37.7, and it was centimeters we were measuring in. Very well done. Please do ask at any point if we're a little bit unsure, and I'm trying to keep an eye on the chat as well so I can check any questions we're not sure of. But that's brilliant. Right, now it says, calculate the radius of the circle with circumference of 15. So this has kind of given us the information a little bit back to front. This has told us the circumference, but we want the radius. Okay, so let's do a little reminder that the circumference equals 2 times pi times the radius. So what I can do is, if I'm looking for the radius, I could do the circumference divided by what? I think some of you may have already said it. I could do the circumference divided by, no worries, that's okay. Let's see how we're getting on. Circumference divided by, good, excellent if you've said it, divided by 2 pi would equal the radius. So that would be 15, the circumference, divided by 2 times pi, and that comes out as, let's see if anyone's got it, 2.39 meters. Check we agree, check I'm right, and see how we get on. Let me know if that's what you got as well. Lovely. So depending on how you rounded it, that's lovely. Brilliant, great work. So next one, calculate the circumference of the circle in the diagram below. What value have they given us? So here's the center, this dot marks the center. What is this value of 3? What have we been given? We have been given this value, which is the radius. So we've got to think, so how do I get from there to the circumference? And well done to those that have already done this, that's superb. Nice and reassuring, but please do tell me if it's still a bit unclear. That's good, and so it's going to be 2 times pi times the radius, which is going to be 18.85 centimeters. Lovely. Brilliant. Well done. So we'll keep going. I'm going to move on to this one now, and then we'll start the sort of next little subtopic after these final couple of examples, provided we're all sort of happy with this idea. But it looks like from the chat, it's kind of making sense and we're all good. Lovely. So this one, calculate the circumference. Remember, we want the length around the edge. Whoops. Given that we've been told the diameter. So I've been told the diameter, I want that length. So that if the diameter is 24, the radius is 12, it's half of that. But I want the circumference. So what I can do here is the circumference be equal to 24, the diameter times pi. Or double the radius, which would be 24, times pi. And what do we get as an answer there? Has anyone got that? Oh, excellent. I see that we're asking about sectors. I'm going to get through this and get through area. If we've got a bit of time, I'll do a quick brief mention on how we do that, but we've got other sort of stuff scheduled. So I'll look at the schedule to see perhaps if that's coming up in a future session. But I know that that's an extension of this that perhaps people struggle with. Sectors are like a pizza slice of the circle. So if you took a radius there, you took a radius there, that bit would be a sector. And that stems from what we're doing today. So that is a really good extension on what we're looking at. Okay, well done to those that got an answer for this. Absolutely right, 75.4 centimetres. Calculate, right, let's whiz through these last ones. Calculate the circumference of the circle with diameter 18. So here we go again, circumference. So you could find the radius and double it, but we've already got the diameter. So it is just 18 times pi. Remember, that's what the circumference was. It was the diameter times by this value. So this will come out as 56 point, well done to anyone who's already got that, 5 centimetres. And then calculate the radius of the circle with circumference 21. So what do we do here? I think we've done one very similar to this. Let's have a little look. Who's got an answer to this? Calculate the radius of the circle with circumference 21. This is the working back one. Brilliant, some answers coming in already. This is the one where we have to do the division. So I've got the circumference, I've got pi as a value on my calculator, and I want to do the division now to find the radius. Now remember that the circumference is 2 times the radius times pi. So if I want the radius on its own, I do the circumference 21 divided by 2 pi, and I get the radius as 3.34. And it's not centimetres, is it? It's metres. Very well done. Okay, it's very easy to put it in the way round that you want it to be. So we've got to be so careful with this in case they ask it the other way. Lovely, right. So I think we'll move on. If you can give me a quick indication, just 1, 2, 3, 4, on how you're finding this. If this is really super straightforward, lovely. I know based on some of your answers, this is nice and clear. If it's kind of okay, but you think I've got to just make sure I've done enough practice before the exam, hopefully I haven't super confused anyone, but be honest with me and do ask the questions if you need help. So that's lovely. And thank you again to all those sharing answers in the chat. That's been brilliant. Right. Good, yeah, so kind of okay-ish for some people, or maybe others have done a lot more of this and they're kind of happy with it. Cool, right, let's keep going. So now another idea that we want to get on to. I'm going a bit fast. Okay, so I'll maybe take it a bit slower here and make sure we're kind of good with this exam kind of practice question, because this is a little bit more involved. So I want to make sure we've got enough thinking time. Let's read through this one and we'll take ideas and suggestions. No worries, that's good. Thanks for letting me know. Here we go. So John has a flower garden in the shape of a circle. The diameter, as we can see, is 5 meters. John wants to put fencing around the edge. So that should be kind of screaming out to us. This has got something to do with perimeter because it's round the edge. And then it says the fencing costs £1.80 per meter. So that's how much it's going to cost for every meter around the edge. It's going to cost that. Right, some people have got there already. That's brilliant, and we'll check that answer going forward. Please do submit an answer at any point, and we'll see if we agree. And also suggestions on how we do this. Excellent. We need the circumference. We need to know how much there is that needs to be fenced, how much of fencing John needs, and then we can multiply that by the cost of the fencing. So absolutely, so the radius is 2.5. The diameter is 5. And if I want the circumference, what calculation can I do? Cool. So I can do, I can do 2.5 times 2 times pi, or 5 times pi. And so that will come out as, I'll write it both ways, 2.5 times 2 times pi, or 5 pi, and that would be equal to, I know it's rounded, but 15.7 when we use our calculator, and that is in meters. Now that's the length around the edge. That is the circumference. Remember the special name for the perimeter of this circle. But what I want to do is I now know that the cost is per meter, so that's handy. It's £1.80 per meter. So all that's left to do is multiply those values together. That's how many meters there are. That's the cost for every meter. So if I multiply them together, we're going to get, and I think some people have done that, 5 pi times, or 15.7 times £1.80, and that will come out as £28.27. So very well done if you got that. And just to talk about sense checking the answer, why have I rounded it to 2 decimal places? Because this is obviously an applied problem-solving question that ties in with an actual scenario. Why have I known to round it to there? Why did I stop? Why didn't I put 28.27, blah, 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 and choose 10 decimal places? What? Excellent, lovely. It is because it's money, it's currency. Think about, in terms of the context, 2 decimal places is really sensible for money, because that's the kind of denomination that we can actually split that into. Lovely, well done. So let's keep going. We'll do another exam style question, and then we'll get on to sort of looking at areas and following on from this. Excellent. So here we go. Here's another question for you guys to think about. This one is a little bit trickier, so I'm going to make sure we've got enough time to have a little think. I'll read it through, and obviously let's keep focused on this one. They are getting a little bit more challenging now. I know when I look at a maths question, there's a lot of words. It puts me off. I want to just get on with working it out. So Raina plans to make a circular garden pond. She's got 10 meters of edging to place around the circumference of the pond. Because of where the pond is to be placed, it must have a diameter that is a multiple of 0.9 meters. And you might think, well, that's oddly specific, but that's what it's telling us. So we need to bear that in mind. It's got to be in multiples of 0.9 that made it a bit weird. Okay. Then it says Raina decides to make the largest pond she can with the edging she's bought. Okay. What length of edging will she have left over? Now there's a lot going on here, and it is only 4 marks. So we've got to be careful, like what are the different bits we need to consider? So give your answer in meters, correct to 2 decimal places. So quite a tricky question. And what we might want to think about first of all is let's look at what the circumference would be, what the circumference could be here. Now the maximum the circumference can be is what? I know, and you're absolutely right. Like there's a lot to process there, and it's only 4 marks. When you think of it in that point of view, there's a lot of words, lots going on. We've got to kind of take the kind of extract the maths we need and work out what it is. So what is the maximum the circumference can be here? So we're going to break this down nice and carefully. She's going to try and put an edge around this the pond. The maximum that can be, well, how much has she bought for the total length around it? 10. Excellent, Lauren. Yeah, excellent. Well done to those that have said that. So the maximum it can be, the maximum this answer can be is 10. Okay, if she's only bought 10, she's not going to have like 12 around the edge. So physically, it can at most be 10. Chances are, with all these calculations, there might be a bit of waste, and we're obviously looking at what's left over, so it won't quite be 10. Okay, so that's good. Excellent. Now, what we've got is, remember that the circumference, let's have a little reminder about what we know. Circumference is equal to 2 times pi times radius, or 2 times the diameter. Oh, sorry, not 2 times the diameter, pi times the diameter, because 2 times r is the diameter. And what has it told us about the diameter? It's a multiple of 0.9. Okay. Yes, absolutely. We'll go through this carefully, just give everyone a chance to have a little think. Because she's only bought 10 meters, the most that this could be around the edge is 10 meters when she lays it all out, because that's the amount she's bought and it needs to reach. It's also said that the diameter, the distance from here to here, has to be a multiple of 0.9. So if we think about what multiples of 0.9 are, I'm going to list them out. We've got, think about the 9 times tables, it could be 0.9, it could be 1.8, it could be 2.7, it could be 3.6, and so on, okay? Does that make sense, the multiples of 0.9? Think of the 9 times tables, then make them 10 times smaller. They are the possible values that the diameter could be, okay? So what we've got is, if we've got a maximum diameter, a maximum circumference of 10, and I know that the circumference equals pi times the diameter, let's work out the maximum diameter. Okay, so if the most that the circumference can be is 10, the maximum the diameter can be, we can work out by doing 10 divided by pi. So for those of you that have done that, if we do 10 divided by pi, we get an answer, I believe, of 3.183. So that's the most that the diameter could be. Excellent. So if that's the most that the diameter could be, and yet we do A-level web classes as well. I'm just checking the chat, trying to keep up with that. So that, yes, excellent, Emma. You make the diameter the subject and you work out what the most that could be is. Now, because it can only be multiples of 0.9, we then compare it back to these. So 3.6 is too big. So the most it can be, the one we have to go with, is 2.7 as the diameter. Does that make sense? And please let me know if I need to re-explain it up to here, because that's not a problem. I know this is a bit of a tricky, involved question. Exactly, that answer is not a multiple of 0.9. So we have to go to our list and find the closest one that will suffice, that will be as big as we can get it before it is too big, okay? So that's lovely, excellent. So now we know that 2.7 is the biggest diameter we can use. We can now work out the circumference if we use 2.7 as the diameter. So the actual circumference that she can get using that diameter will be equal to pi times 2.7. And has anyone got that? Has anyone got a value for that? Excellent, 2.7 times pi, that's going to come out as 8.48. Yes. Now, please do ask if we're still a little bit unsure. That is the actual circumference. Now, it's always this point in the question, and I still do it now. I have to remind myself, reread the final bit the question asked me, because I've done all this work and I feel like I'm there, but I might not be answering the question. This is where I have to go, is that what it wanted? Read it again. Excellent. Vikash, well done. That's absolutely right. It said, what is the length of edging she'll have left over? Because she's not going to use the whole 10. She's actually only going to use 8.48. So sneakily, that's not the end. You've got to take it away from 10 to see what's left. So what we have to do, so finally, we have to do 10 minus 8.48, and we're left with 1.52 meters left over. That is the actual answer they want. So there were a lot of steps there, but I think the key bit at the end was referring back to what it actually asked us, because that's what a lot of people's downfall are. They do all this work and they've got numbers everywhere. They think, I think I've done it now. A number's popped out, but they haven't actually referred back to what the question really wanted them to find. So always do that. Brilliant. Right. So I'm going to move on. Before I do, are there any things we want to check or comment or say about that you might want me to just go over or explain again? No problem. I just want to make sure we're all happy with that. Yeah, so basically, if I just re-explain it quickly overall, what we did was we found the multiples, the diameter could only be multiples of 0.9. So I listed them out, 0.9, 1.8, 2.7, 3.6. And I thought, let's find the maximum the diameter can be. So to find that, I did the maximum circumference, 10, because that's how much she bought, divided by pi. The biggest the diameter could be is 3.183 meters. Comparing that to my list of possible diameters, the biggest one I could actually use was 2.7. So I thought, okay, I'm restricted to using 2.7 now. Let's work out the circumference with 2.7 as the diameter. When I did that, I did pi times 2.7 and got 8.48. And that's the real circumference she'd end up with if she used 2.7 as the diameter. At this point, we feel like we're done, but we have to go back to the question and think, it asked me how much will be left over. She bought 10, the actual circumference has come out as 8.48, so I have to take that off of 10 to see what's left over. Good, because it says what length of edging will she have left over. She bought 10, we've worked out she's going to use 8.48, so to see what's left, that's why you take away that number from 10, because you're not going to use all of it. There's going to be this sort of residual spare bit that doesn't get used. Is that okay? Yeah, get the leftover, because we're not actually looking for the circumference, we're looking for how much wastage is there, how much like sort of spare. Yeah, and you know what, this is something I think is probably the biggest thing even at A-level maths, that people do the question and they've done the bulk of the work, they think they're done, and the question's asked something a little bit random at the end, and you've got to think, have I actually answered what they said? I've done all the work, I've just got to remember, oh, it wanted what's left, so I take it off of 10. Is that okay? Lovely, brilliant. Thank you for asking that question though, because hopefully that's cleared it up for a few people there. Brilliant. So this is on until we should be done about 6:30, hopefully, or maybe a bit before, and I'll answer any other questions. But that's a lot of marks, I know. So that's why a good sort of breadth of practice of this stuff is really handy, so we get used to the type of question and what to look out for. Brilliant. Sorry, so yes. And thank you to those of you that as well are explaining and commenting in the chat. It does really help if we can sort of discuss it. And that might be something you're sort of missing at the moment, not being able to sit with someone in school necessarily. So it is great if you can share your answers and your thoughts in the chat. Thank you for doing that. Right, let's look at the area now. Lovely. Right, so we kind of alluded to this earlier. We mentioned about areas earlier, about the 2D space inside a shape. We can derive the formula for the area of a circle basically by splitting it up. So it is just a formula you need to know. So we know that the circumference now is pi times the diameter, or double the radius times pi. But I'm going to get the formula for the area of the circle. Does anyone know it? If you know it, I think some people have shared it already, but they might not have seen where it comes from before. And I've seen some really cool, quirky animations of this on Instagram, Twitter, where they do it really nicely and visually. So that's kind of cool. And I think it's important that we kind of appreciate where it comes from. So splitting up the circle and rearranging it. And I'm going to show you kind of how this is done. It's a little bit abstract and weird, and you're not going to be required to draw this out in the exam, but hopefully it will help us gain a sense of why the area has this formula. So imagine I split this circle into loads and loads and loads of little chunks, equally sized chunks, or as someone quite rightly referred to them earlier, they would be called sectors. Okay, so these bits that stretch to the middle, they're kind of like little triangles with a kind of arc on the edge instead. And if I made loads and loads of these, I split the area up like that. Are we happy? As they get smaller and smaller, they start looking more and more like a kind of really skinny triangle. Okay, and what you could do is all of the lengths of them are going to have the same length edge. It's all going to be the radius. I'm going to do that in black so it's clearer. The radius would be the length from the center to the middle. So if I rearrange them, I'm going to just, thanks very much. I'm going to do this really quickly because, as I said, it's a little bit abstract and quirky and it won't be something you have to replicate in the exam, thankfully. But I'll show you what we'd get is if you lined them all up like this, and I've picked something that's going to take forever to do, and hopefully we can see what I'm doing here. Oh, messed it up. And I've chopped them all up and I lined them up upside down next to each other like that. And I kept it going, and I'm going to pretend I'm really quick at drawing, but I'm not. And I kept doing that. What we'd end up having is, imagine that was the whole shape all done. The length from there to there would be the radius. And what the length would be along, if I kept it going, can anyone suggest what the length would be if I lined all the slices up? If I paired them up, put them upside down next to each other, are we happy that they would be half of the circumference? Half of the circumference, because you've doubled up, would be the other length of that sort of rectangle that it's producing. Yes, we're on the right lines. So it would actually be the length along here would be, remember the circumference was 2 pi r, or pi times diameter. So half of that is just pi times r, pi times the radius. So I could cut these into lots of little strips, rearrange them next to each other like that, and it would be half the length of the whole circumference because I've doubled up. And the other edge would be just the radius from the center to the edge. So what I'd have is I'd make this sort of rectangle looking thing that is basically the radius times pi times the radius. They're the dimensions of the new shape. So it would be this by this. And if I times that together, I get pi r times r, I get pi r squared. And that is the formula for the area of the circle. So apologies, I've taken a few minutes to explain the thing we ultimately want, which is this. But for those of you that have seen that before, that's lovely. Yeah, there's some really nice animations that bring this to life. And obviously it's not something you're going to need to replicate in a maths GCSE exam, but it is a really key formula you need to know, and it helps if you understand it. So that's great. So pi r squared is what we're using. That is the area of a circle. The area of a circle is pi r squared. So let's give that a go. So the area is, moved on by mistake, sorry, pi, oops. Pen's been a bit funny now. Pi times the radius squared. So the radius times itself. Pi times radius squared, or shorthand, pi r squared. Now, BIDMAS or BODMAS, or whatever you want to call it, is important here. We square the radius, then times it by pi. Okay, so lovely. Right, cool. So calculate the area of a circle with radius 5 centimeters. If you guys want to submit some answers to that, tell me what you think that would be in the chat. That would be brilliant. And what we've got is we're going to work out the area then using that little formula there. So that will be pi times the radius 5 squared. Now you do the powers first. So 5 squared is 25 times pi, 25 pi. And if anyone's done that already to a few decimal places, excellent. Thanks very much. And also, I'm being picky here, but also what units would we use? We're dealing with a 2D space. And well done to those that have done it to a different number of decimal places. That's absolutely fine. What will we use as our units for this? This is an area. So it was in centimeters. The length of the radius was in centimeters. I found an area, so it will be centimeters squared because it's a 2D space. So this is different. It's a different quantity we're finding now. Right, over here, we've got area, and that is going to be, this time, pi times 4 squared. And feel free to work ahead of me and share answers for this one. I think some of you already have, so very well done. So that will be 16 pi, And on your calculator, we're going to get 50.3, and this will be meters squared this time. Lovely, well done. Cool, so hopefully that's nice and clear as well. Well done to all of you with that. I'm just going to take this opportunity to just check if that's okay, or if anyone wants me to clarify anything to that point. Is that all okay? Yeah, I'm going to get a move on so we can get through this. We are nearly there with what I had planned. So calculate the area of the circle with diameter 20. So what we've got is we've got a diameter, and we've got a formula that involves the radius. So if the diameter is 20, what is the radius? Remember, radius is half the diameter. So we're going to get 10 centimeters there. And that's great. And then to find the area, you know what to do. We're going to do pi times the radius squared, which would be 100 pi, which actually comes out as 314 to three significant figures, centimeters squared. You might have included some decimals, which is fine, but that is going to be our area for that shape. Calculate the radius. Here we go. Here's another kind of back to front one. Very well done to you guys there. Thanks for that. This is the one where you're given the area now. We want the radius. So as some of you mentioned earlier, it's that sort of rejigging, rearranging process. So what we've got here is we know pi r squared equals 10. So the first thing I'm going to do is divide by pi, which you can do on your calculator, and that would be the radius squared. And then how do I undo a squaring process? If I've got the radius squared, I don't want the radius squared, I want the radius. How do you undo it? And a lot of people say, oh, just divide by 2. It's not 2r, it's not 2 times the radius, it's the radius squared. You do the square root. Excellent. So the radius would be the square root of 10 divided by pi. So it looks a little bit complex, but what we've done is essentially just undone that process carefully. And well done to anyone who's already got an answer there. It is 1.78 meters is what that sort of spits out. Well done. Excellent. So this one here, calculate the area of the circle in the diagram below. So we want all this 2D. Oh no, yeah. Why was that answer meters? Why wasn't it meters squared over here? Well done to those that have done the next one already. But just going back to here, why was my answer in meters for that question? 1.78 meters. Well, think about what I was finding. I wasn't actually finding the area that time. I was finding the radius, which is the length. So that's right. Right, so for this one here, well done to those that have done it. We've got the diameter. So we know that the radius is 9. The radius is 9. So the area, for those that have already whizzed through that, is pi times the radius squared, which will be 254.5 centimeters squared. Well done. Lovely. Right. What we'll do, because I am kind of mindful of the time, I'll do a quick checkpoint here. How are we feeling with the area stuff? So area of a circle, pi r squared. I've had a little bit of a visual insight into how that works. How are we feeling with that? Just do 1, 2, or 3 to give me a quick indication of if it's okay, or you're kind of, it's still sort of new and you're kind of working on it a bit still, or if it's actually quite confusing, be honest, but hopefully that's all right. Lovely. Well, that's really reassuring. And thanks again to everyone for working through that so carefully. I think this would be a really good opportunity to now look at another sort of final exam question on this, a bit like the last one. So we're going to take this in, process this one first of all. And again, it's like, oh no, this is really full on maths that could hurt my head if I overthink it. We've got this diagram. Let's break it down. 3 marks. And actually, it's not too bad. So let's have a little look. So this one here, we want to find the shaded area, that little chunk at the top. Okay, I know, but it's not bad. We're gonna think about it carefully. We know how to find the area of a circle now. We know how to find, all of this space using pi r squared. You guys also hopefully know how to find the whole area of the square, because it's just 12 by 12. So we can think about, well, how do I get that little chunk? I know how to find kind of big bits here. So to find the area of the square, we just do the 12 times the 12. So the area of the square is what? And sometimes doing all this circle work can confuse us over stuff we've done ages ago. So this one will be, area of a square will be 12 centimeters times 12 centimeters. So 144 centimeters squared. Do we all agree with that? So that's the whole entirety of the space occupied by the square. Lovely. Now, oh, thanks guys, you can make me a bit big-headed here. But really well done. We're gonna finish this off because this is the last little bit. 144 centimeters squared. Now, the circle, can anyone tell me, I don't know if anyone's got it already, the area of the circle that we are trying to account for? Okay, right. So the area of the circle, the radius is 6, pi r squared is going to be pi times 36. So 36 pi. Okay. Now, what you might have noticed is if you do 144, the whole square minus the circle, is everyone happy? That would leave all these 4 outside bits, including the grey bit we want. If I do the square area, take off the circle, I'm left with those residual little chunks around the edge. Okay, so we've got to be careful here. So what I'm doing is basically, oh, I keep moving on. I'm not desperate to finish, honest. Here we go. If I do 144 minus 36 pi, and I take that away, that's all the bits around the edge. Okay, 4 bits around edge. Is 144, the whole square minus 36 pi. But I only want one of those 4 bits. Brilliant, excellent, Mohammed. So we're going to divide that by 4 to get one of them, because I just want that one grey area. So if I divide that by 4, I'm going to end up with, has anyone got an answer here? Now it does say in terms of pi. So what I'm going to do is I'm going to say 144 minus 36 pi divided by 4. And that will actually equal 144 divided by 4 is 36. 36 pi divided by 4 is 9 pi. That is your answer, centimetres squared in terms of pi, which feels a bit weird, but that's it. You could find it as a decimal on the calculator, but the question actually asked for it in terms of pi. It was truly epic, that one. Well done. Hopefully that's clear, but the actual process takes a minute to visualize. And then actually once we've got it, it is just working out a few areas and taking them away. Right, great, lovely. So what I'm going to just do, because I'm mindful of the time, we've got to wrap this up shortly. What we've done today, we've looked at the key components of the circle, the keywords. A lot of you were very familiar with them, and introduced some new ideas as well. We defined pi as a number, just over 3.14, blah, 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 and calculated the circumference. And then we found a way to find the formula for the area of the circle. So that's great. So for some people, this was very much a revision. For others, there might have been some new ideas mixed in there in light of some GCSE questions. So if you have any questions, you have been asking and stuff as you've gone, but I think we've largely worked through it together. What I would just like to say, because we're kind of getting towards the end, is if you could set a reminder, we've got lots of web classes coming up. So we've got the sciences, maths, they're the days that they're happening at the moment. That's lovely. I'm very happy to hear that. That's great. As I said, don't forget about this. There are some free accounts being given away for the remainder of this academic year. So please sign up for the mailing list if that interests you and you think it will help. And that would be great to get you on board with the Snap Revise platform and everything we have to offer. Lovely. Well done. Thanks again, everyone. Very well done today. I'm going to stop sharing that there and just say, yeah, I hope you all keep well. And it'd be great to see you again at some of the future sessions that we're going to be running. Really well done, guys. Take care and have a good evening. I'll speak to you all soon. Well done. Thanks.